So here you have this complex fraction. You have a set of fractions in the numerator, a set of fractions. Again, I'm going to write everything as its own fraction in the denominator. And so when you're looking at this, you can either use method 1 or method 2. Again, it really doesn't matter. And I'm going to go ahead and just use the first method. I'm going to combine everything in one fraction in the numerator, combine everything into one fraction in the denominator. So in the numerator, my LCD is a y and a 2y plus 1. So when I look at my first fraction's numerator, 5, I have to multiply that by the LCD factor missing from its denominator. It's missing the 2y plus 1. Minus the next fraction's numerator, 6, times the LCD factor that's missing from that fraction's denominator. It's just missing the y. So if I continue to simplify this, I'll distribute my 5. I get 10y plus 5 minus 6y, which leaves me with a total net of 4y plus 5. That's all over this LCD y times 2y plus 1. Okay, so there's my numerator written as a single fraction. So I'm going to do the same thing now with my denominator. I'm going to write it as a single fraction as well. My LCD is y and 1, so the only factor I need is a y. I take the first fraction's numerator 5 times the LCD factor that's missing from its denominator. It's not missing anything, so I just leave it as a 5 or think of it as 5 times 1. Okay, plus my next fraction's numerator 4 times the LCD factor that's missing from its denominator. It's missing the y, so I multiply that. And so here I wind up with my denominator just being 4y plus 5 all over y. Again, all I did here was I reordered my terms. Okay, and so this is the denominator written as a single fraction. So now what I'm going to do is I'm going to use this fraction bar of my complex fraction, and I'm going to convert it into multiplication by inverting and multiplying. So instead of dividing by this quantity, I'm going to multiply by its reciprocal. So the y from the denominator gets moved up to the numerator. The 4y plus 5 gets moved to the denominator. And now as I simplify through this process, my 4y plus 5's cancel, my y's cancel. I'm left with 1 over 2y plus 1. And here, again, the advantage to using this step is you can often see the factors that get canceled from your denominator. So I see the factor of y gets canceled, so I know that y can't equal 0. I also know that y can't equal a factor of the value of y that would give you a 0 for this factor. And again, the easiest way to do this is just take the opposite of your constant divided by your coefficient of y. So the opposite of 5 is negative 5. Divide by the coefficient of y. So negative 5/4, and 0 would be your two restricted values. And now remember, since you did invert and multiply, you do have to pay careful attention that all factors in this fraction that you inverted and multiplied, every single factor can never equal 0, whether they're canceled or not. It turns out in this problem they both got canceled, but that's not always going to be the case. And so even if there had been a factor right here in the numerator of this form that wasn't canceled, you'd still have to restrict its value in the domain restrictions.